Hey grade 5. One of the biggest jumps in difficulty in this year's math comes from the move to multi-digit multiplication. Now, in the past, you've multiplied 1, 2, or maybe even 3-digit numbers by a 1-digit number. This year, we start multiplying 2-digit numbers by other 2-digit numbers, and that can be a lot to wrap your head around. Now, in my class, we talk about 3 different methods that can help you to do this, and students are encouraged to choose a favorite and use it as much as they want. As such, I've made 3 different videos, one for each method. So pick the one you'd like, and we'll go from there. Good luck! This video is to review the standard algorithm. Now, for all of the parents out there that complain about new math, well, stop it. You're giving your child tacit permission to give up on math by modeling a disdain for it. Second, this is the method that you like. It's the one that you, I, and all of the other olds out there learned in school. Depending on who you are, this is either the method you're very comfortable with, or the point where you started down the path of misleading yourself that you're bad at math or math isn't your thing. Now, the biggest stumbling block for students when they use this method is that it requires more understanding up front. Before you can use this, you need to have an understanding of how to multiply larger numbers by 1 digit. So we're going to start with an example of how to do that just as a refresher. Here we go.
Now first, we need to remember that all of this takes place one place value at a time. That means we start by multiplying the ones of our larger number by our second factor. In this case, that's 7 times 6, which hopefully, if you know your times tables, you know is 42. Now, my 2 goes down below here in the ones place because that 2 is going to stay in the ones. My 4 tens I'm going to set aside later because I'm only working with the ones. I need those tens eventually, but not right now. So I'm going to put the 4 tens up top so I remember they exist, but know that I'm not using them right this second. Now that I'm done with my ones place, I need to multiply the tens place by my second factor. In this case, that is that 5 times 6. Now 5 times 6, I hope you all recall, is 30. But since I'm talking about 5 tens times 6, I'm not talking about 30 ones anymore, I'm talking about 30 tens. I set aside 4 tens before, so I need to add those back on now. 30 tens and 4 tens is 34 tens. Now that I have that, I can write them down below, which gives me my whole total of 34 tens and 2 ones, or 342.
Now that we've got that method down, we can look at how to move it on to more than 1 digit at a time in our second factor. Now, this isn't that difficult, and it's not really any different except for one small thing. We do still need to remember one rule about our place values. That is, multiplying by tens gets you an answer in the tens. Multiplying by hundreds gets you an answer in the hundreds, which means that our products here are going to have an extra 0 or 2 on the end, depending on what place our starting digit's in. Let's take a look at how that looks by wrapping up this example problem.
Now, the trick here is that we're treating each digit of the lower problem as its own smaller problem in the whole thing. That means we're not doing 17 times 54. We're actually doing this. 17 times 4 and 17 times 50. 50 17s and 4 17s should make 54 17s. I've got 50 17s that I'm combining with another 4. So if I take these problems one at a time, I could do them like this. With the standard algorithm, we write it all in one place and stack things on top of each other so that we can add them up later. Let's go back to that page. Now we're going to start by doing the same thing we did before with the other problem, and just multiplying 4 by 17. I'm going to do this color-coded so that it's a little bit easier for you to see. Now 4 times 7, again, I'm trusting you know your times tables here. This does all depend on you knowing your 1 to 9 times tables. 4 times 7 is 28. So I put my 8 ones down below and set aside my 2 tens to add back on later. 4 times 1 is 4, so that's now 4 tens. I've got those 2 tens I set aside, add them back on. My 4 tens of my product with the 2 tens I set aside comes to 6 tens. So 17 times 4 is 68. Now I'm done with that 4. It's finished, but I still have that 5 that I haven't looked at. So the next step is 5 times 17. Now it's not quite that easy. We do need to remember one more thing. This isn't 5 ones we're talking about. This is 5 tens. When I multiply any number of tens by something, my answer has to be in the tens as well, which means my ones place is going to be a 0. I'm not going to have any ones in this final answer. So I can start by putting my 0 down below. Now I just solve 5 times 17 the same way I would have any other time. 5 times 7 is 35. I put my 5 in my tens place because I'm talking about tens now, and I set aside my 3 hundredths to be added on later. 5 times 1 is 5. Now that's 5 tens times 1 10, which comes to 5 hundredths. I add my 3 hundredths to those 5, and I've got 8 hundredths, which means 50 times 17 is 850. Now I've got my answer to 4 times 17, and I've got my answer to 50 times 17. If I add both of those answers together, 50 17s and 4 17s should make 54 17s. 8 plus nothing is 8. 6 plus 5 is 11. Carry my 10. 8 plus 1 is 9. So 17 54s, or 54 17s, comes to 918.
Review complete! Now, no matter which method you were watching today, I hope this has been a good refresher for you. Or if this was your first time checking out this method, I hope it was an enlightening experience for you. Multiplying larger numbers is one of the first times that students really stumble with their math, especially in grade 5. But none of it's actually that hard as long as you're comfortable with your 1 to 9 times tables and be careful to follow the steps properly. No matter what your method of choice is, I hope you're better equipped after this to tackle those larger problems. Good luck, guys. Have a productive day. Peace.